Hello everyone, this is Mr. Shell, and today we're learning how to properly create a line graph. Obviously, the first thing to do when you're creating a line graph is to decide where the information will be graphed. So are you going to use what type of grid paper are you going to use? Are you going to use Microsoft Excel? Are you going to do it in Paint? Are you going to do it in Microsoft Word? So you're deciding where you're going to display this information. Next, you're going to choose the scale so the graph becomes large enough to fill most of the available space on the paper or on the graph, right? You don't want to have this big, this big grid paper and only take up a really small part, because it's going to be really miniature and it'll be hard for people to read and understand. And we'll talk about going over the scale when we do the example. Next, each regularly spaced division on the graph paper should equal a convenient constant value. We'll go over this also, but you want to pick a value so that you fill most of the space, and it has to be consistent with each spaced division on the graph. You want to label each axis with the quantity and the unit being graphed. So you need to make sure that you label your axes, and you also need to make sure you put the units in your label of the axes. And then you also need to create a title for the entire graph. Okay, then you're going to plot each point. If you plot more than one curve or more than one set of data on the same graph, you want to make sure you use a different color or a different shape so you can distinguish each set of data. If I'm plotting two different sets of data on the same graph and I'm using the same color and I'm using circles for my data points for each set of data, I'm not going to know which is which, and it's going to be really confusing. So ideally do both. Use different colors and use a different shape like a triangle or a rectangle or something like that if you are plotting two sets of data on the same graph. We won't do that today, but in a future video we will. Then you're going to connect the points. If you're doing that, sometimes you'll be making a trend line. Today we're just going to connect the points. In a future video we'll go over how to create a trend line and how to calculate the slope of a trend line. Then you're going to make sure, as I said in the previous slide, title your graph with a title that's informative, so who's ever looking at your graph knows what data is being displayed. Someone should be able to look at your graph, read the title, read your axes, and understand what the data is in the graph. Now the last thing before we do our example is the two axes in a graph. We have the x-axis and the y-axis. The horizontal one is called the x-axis, and it's used for the quantity that can be controlled or adjusted. It's your independent variable. So your independent variable always goes on the x-axis, and that's something that the experimenter or you can control. A lot of times, time, if you have time is always going to be the independent variable. On the vertical axis, it's used for the quantity that responds to changes in the quantity on the x-axis, and that's called the dependent variable. So the dependent variable will always go on the y-axis. The independent variable always goes on the x-axis. And you can think of the dependent variable as that's kind of the data. That's the data that you're measuring. So if you're doing an experiment, or if a scientist has done an experiment and you're looking at data, whatever data was measured, that's going to be the dependent variable. So that could be the temperature. You can measure temperature, you can measure height, you can measure concentration, you can measure mass, like in grams or kilograms. Those are all dependent variables because they're the data that we collect. Okay, so now on to our example here. Get my pen out. And we're going to go ahead and graph this data. So the first thing we're going to do is label our axes. And we'll notice we have time and height. So we need to identify the independent variable and the dependent variable first. So as we said, time is, if you see time, that's almost always going to be the independent variable, right? So let's label our our x-axis down here, time, and then you always need to put your units. So here our time is being measured in years. Because if I don't put the units, I don't know if that time is measured in hours or minutes or seconds, right? We just have 1, 2, 3, 4 through 10. I don't know what those are unless I label them with units. So we have years. Then our dependent variable is going to be our height. That's the data, right? We can measure that. We can measure height. I can get a tape measure or whatever, and I can measure someone's height. So we have height, and our unit is inches. So let's put height right here, and we'll abbreviate inches as IN. Okay, so we've labeled our, remember this is the X axis, and then up here is the Y axis. Now we need to create our scale. Now scale means how much are we going to go up by for each line here. So with our time, notice we're going 1 through 10, and how many lines do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's perfect. Each line, each dash on the grid mark here can be worth 1 year. And we could even start 0 here, and then 1, 2, 3, 4, on up through 10 years. Now the y-axis is a little bit trickier. Notice we start at 32 and we're ending at 59. And let's count how many grid lines we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again, right? So we don't really want to start at 0 though, because we don't have anything between 0 and 32. That would make our graph, maybe we'd only have a graph in this upper part here, and we don't want that. We remember the rule, we want to take up most of the available space. So we can start this, let's start this at 30. This line here is going to be 30. And then, to take up most of this available space, we could go up by 5s. So 35, 40, 60. Now notice we're kind of at an awkward number here, and so we don't take up quite the entire graph, but we get fairly close. We get about 2/3 of it. Now you could go up if you wanted to. You could probably time it and go up by like 3s or 4s here, but as long as you're getting most of it, then we're okay. So we have labeled our axes, we've chosen our scale. Now we just need to plot our data points. So our data points here, these are our X data points, these are the Y data points, right? Because time is on the x-axis, so these are our X data points. And then height is on the y-axis, so these are our y data points. So let's see, our first data point is 1, 32. So I go over 1 on the x-axis and up 32 on the y, and I'm right about here. Next we have year 2, we're at 36, so I go to about right here. 339, 443, 545, 647, 750, 854, 956, and 1059. And then for this graph, we're gonna connect the dots. Now I would not start down here. I would not start right here because we don't have a data point for that. We don't have a data point for when X, for when the time, the years is 0. We start at 1 years old. So we're going to start right here. We're not going to draw a line in this area between 0 and 1. And now we're just going to connect the dots. Remember, you don't always do this. Sometimes you'll draw a trend line, but that'll be in a different video. And so now I've connected my dots and I have my line graph. Now the last thing that we have not done yet is make our title for the graph. And the title should be descriptive so someone can understand the graph. Even if they just walked in and looked at your graph, they would understand what it is. So we can say, let's call it change in height as years increase. And we could even get more specific. If I had told you that this is like a human, the growth of a human baby, right, from the time they're 1 year old to the time they're 10 years old, we could go change in height of a human as years increase. And then someone would understand, if you came in and read this, change in height of a human as the years increase, you would say, oh, okay, so at 1 year old, this baby human was about 32 inches tall, and then at 2 years old, they were about 36, and so I would be able to understand this data just by coming in and looking at the graph. So that's all for today, and I hope it helped.